Alright, this is a section of my K8048 PIC development board. Alright, big deal. I'm blinking an LED. What do you need to blink an LED? Well, you need to turn it on and off, and you need to put time delays. Delay it off and then delay it left on so you can see it. Otherwise, it's just going to appear like it's on all the time and a little dim. So we're going to look at software timing loops. And in a separate video, I'll look at hardware timer-based timing loops. Alright, I'm going to discuss timer 0. This PIC16F84 has only a single timer, timer 0. It is, of course, an 8-bit timer with an 8-bit preload register. You have a selection, and by the way, there's 2 additional timers plus this one on the PIC16F8628 and other chips. Nonetheless, we have a choice of 2 clock sources. The internal oscillator, assuming I'm using a 4 megahertz crystal, which is what I usually do on these, that frequency of oscillation will be divided by 4. On the other input, if I choose to use it, you can use the external pin, RA4. It could be an external clock of some time. Maybe you have a 32 kilohertz oscillator to sync up maybe a real-time clock. You could always send it in on RA4, and you can select the edge bit for that. All of this, by the way, is in the option register we will see momentarily. For this discussion, I'm going to stick to the internal oscillator. At 4 megahertz, it's going to be divided by 4 and produces a 1 megahertz clock. My TOCS bit in option register, which is bit 5, I can set it to 1 to select the external clock, or I can clear it to select the 1 megahertz coming in. This discussion, I'm going to use the 1 megahertz. Now we have something called the PSA bit, bit 3. I can make a decision here to send the 1 megahertz clock directly to timer 0, or I can run it through a prescaler, which has 3 select bits of its own. Bits 0, 1, and 2, it will select up to a division of 256. So 1 megahertz, which has a period of 1 microsecond, divided by 256, can give me a period of 256 microseconds. I can select one or other with the PSA bit. I will be using the prescaler divide by 256, so I will be setting this bit to 0, then it runs to my timer 0, and it will count until it overflows, where it sets a flag bit. Now, I'm not going to be using the interrupt function in this. That's for another video. So the idea is this. My oscillator comes in at 4 megahertz. I'm going to divide it by 256. I'm going to preload a value to the timer 0 register that's in bank 0. When this thing say I put in 100, then 256 clock pulses later, 156 clock pulses later, it's going to overflow and set a flag and do nothing until I clear the flag and preload the register again. I could have always loaded the timer 0 with 0 and overflowed it at 256, but there's a reason I will put a value in this register before I start the count. Here's a view of our option register. As far as timer 0 is concerned, bits 0 through 5 involve timer 0. Bit 6 is related to an interrupt function, and bit 7 will pull up the port B internal pull-up resistors. So we're only interested in bits 0 through 5 in relation to timer 0. As we discussed before, TOCS, this is connected with the external clock outside the chip. RA4, if it's set, we can go from RA4, 0, we use the internal clock, so we'll clear it. This is the timer 0 edge select bit. That is only related to using RA4, so I would just leave it 0 for my purposes. Now we're going to have the Prescaler Assignment bit. Prescaler is that 256-bit prescaler I told you, divide by 256 I told you about earlier. High, it will go to the watchdog timer. Of course, I want to assign it to timer 0, so I'm going to clear it. Down here, let's see if I can zoom that in a little bit better for you. All right, these 3 bits here, 0 through 2, you can set these to divide 1 to 2, 4, 8, 16, 32, 64, 128, 256. It's a little different if you're using it with the watchdog timer, which we're not using here. So in this case, I'm going to be setting it, all 3 bits, to divide by 256. All right, here is my setup for the program. Not a lot to it. I have to jump by setting RP0. In the status register, I have to jump to bank 1. And I'm going to save this value, which when you look at the bits, here's the 3 to divide by 256. This one sets the prescaler to go to timer 0 and so forth, as we discussed on the page with the option register. Nothing else much to it other than I got to jump back, clear RP0 to jump back to bank 0. Here is my program in loop. It's just this part here. I'm going to move a value into the working register. I'm going to XOR it with port B, store it back in port B. That's what's blinking your LED on and off. Then I'm going to call the routine timer 0 delay. Let's look at timer 0 delay. All right, this is the entire timer 0 delay routine. This is a subroutine that I jumped to from loop. I set up the hardware timer circuit. When I divide 1 megahertz by 256, that produces a count or a tick once every 256 microseconds. Well, 256 microseconds times 196 gives me 50 milliseconds. So every 50 milliseconds, that timer is going to overflow. How did I get to 50 milliseconds? It's an 8-bit timer. So what I did was preload the value of decimal 59. I moved it into the timer 0 register. That's bank 0, location 0x01. Now, what is there left to do? Of course, I have to clear the interrupt. I have to clear the timer 0 interrupt flag. So bit clear file, interrupt, the interrupt control register. I'm not using it as an interrupt. I'm just checking the flag. And I clear the register. Now I'm going to come here and I'm just going to sit here and wait and wait and wait to wait for the flag is set. Once the flag is set, I jump the go to -1. I decrement the count in 1. Remember, I loaded count 1 with decimal 5 right at the top because I want a delay of 5 times 50 50 milliseconds, which is going to be 256 millisecond delay. I'm going to decrement file, skip at 0, count 1. Now, if it isn't 0, I'm going to go right back up here. This is how it works. Go to $-6. 1, 2, 3, 4, 5, 6. I'm going to load my preload value, decimal 59, once again. It's going to put it in the timer 0 register. I'm going to clear the overflow flag. Then I'm going to sit here and wait. After doing this 5 times, count 1 will be 0. I will skip the go to -6, and it will issue a return, and I will exit the subroutine. And that's what you do to use a hardware timer to do delays for blinking your LEDs or any other function. We'll be looking at in another video of a more sane way to use software delay loops to do the same thing. So that's hardware timers without interrupts. Thanks for listening to the video. Catch my website at www.bristolwatch.com.